Hello and welcome everyone. My name is Dane Menke. I am the Digital Marketing Manager here at Regenesis and Land Science. Before we get started with the webinar today, I have just a couple of administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we do not address your question, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will focus on design tips for effective vapor mitigation planning and implementation. With that, I'd like to introduce our presenters for today. We're pleased to have with us Spencer Cox, Project Environmental Specialist at United Consulting. Spencer Cox has more than 10 years of experience in environmental consulting. As a technical advisor specializing in vapor intrusion practices, he excels in field sampling, data analysis, risk assessments, technical writing, and personnel management. He has extensive experience reviewing complex sites, conducting site investigations, and implementing mitigation strategies for existing and proposed buildings, following state and federal assessment protocols. We're also pleased to have with us today Jason Wilt, Southeast District Technical Manager for Land Science. Jason Wilt is responsible for assisting our client partners with technical support in the evaluation, design, and installation of TerraShield, NitroSeal, MonoShield, and RetroCoat vapor mitigation systems. Jason also works closely with the regulatory community to advance guidance and understanding of vapor intrusion barrier technologies, implementation, and QA/QC best practices. All right, that concludes our introduction. So now I will hand things over to Spencer Cox to get us started.
Thanks, Dane, and welcome everyone. For an overview, we thought it would be important for everyone to see that mitigation is a multi-step process. It involves multiple stakeholders throughout the process. We'll briefly discuss what is vapor intrusion from the consultant and from the mitigation perspectives, the strategies that go into evaluating and selecting products, and design implementation coordination. Lastly, we will discuss some case study scenarios that will give you a perspective on the simple, the unique, and challenging mitigation techniques. So you're a few slides in and wondering, what is vapor intrusion? Vapor intrusion is not a medium like soil and groundwater. Vapor intrusion itself is a pathway between the contamination of a volatile substance, be it in soil, groundwater, or a vapor phase, and a receptor in a building. These receptors can be businesses, multifamily dwellings, or single-family structures. Any enclosed structure and an occupant can be a receptor for vapor intrusion. The exhibit image you see on the screen gives a lot of information for the reader. You can see soil contamination that migrates to groundwater, then volatilizes back through the subsurface and into structures. It's just one of dozens of what we refer to as preferential pathways that we evaluate as professionals when evaluating the potential development or an existing structure. No site is ever truly the same, whether it's the design, the end use, be it residential or commercial, or the contaminant levels present. So why do we care? Ultimately, these substances can pose a threat to human health. VI is primarily associated with volatile organic compounds and some semi-volatile organic compounds. There are definitely other niche sources out there to look at, such as pesticides, polychlorinated biphenyls, and mercury. More commonly, the concentrations of vapor chemicals are not high enough to pose an explosive risk or health effects due to short-term exposure. However, the presence of low concentrations of chemicals in indoor air may pose a risk of health effects due to long-term exposure. Thus, investigations of vapor intrusion pathway and risk assessments are needed to develop a conceptual model and evaluate that risk into the future. In some situations, This can be complicated by the presence of some of the same chemicals in household or business products, such as solvents, paints, gasoline, dry cleaning clothing, and cleaning agents. These products may pose separately or combined with vapor intrusion a human health risk. When evaluating the potential for VI or an active VI situation, we immediately look to a checklist of potentials to rule out. In some cases, the risk can be literally right under your nose. In existing construction, we look at, is there an acute health effect going on? Is someone getting sick? In some cases, chemical odors can be indicative of situations that require a prompt response action. Understanding the potential indoor sources is important. In these situations, it is important that your consultant is vigilant of the potential sources and the health effects. When we look to due diligence acquisitions, is the source on-site or is it off-site? And how could that pose a threat to a future occupant? Sources for VI can come from multiple locations, and understanding these sources play into the mitigation you select. When evaluating for VI, risk evaluations are taking into account the potential for chronic health effects, i.e. cancer risk or long-term action levels. Vapor intrusion is an ever-evolving science. I am sure some of you have definitely heard this terminology. It means that there is a characteristic change in our understanding as we learn more about chemicals, their properties, and how it affects the human body over time. In some cases, some of the shown products in the image were deemed safe for use not 5 years ago. Most, if not all, of the products are still available and in your home. These are floor cleaning products, air fresheners, aerosol products. Many of these industries and companies have made changes as they have found that the properties of their products have household contaminant effects for folks and have changed over time. But where does that leave existing products on the shelves? And then lastly, but as important, the unknown neighbor. Whether you're developing near a busy roadway, highway, or a large industrial building, can you predict the potential future risk to your development or existing property from chemical releases? Will your occupants be safe without mitigation? Understanding the source allows us to understand the appropriateness of mitigation technology we select. In some cases, you can have groundwater impacts that do not pose a threat to vapor intrusion. Guidances from federal and several states provide separation distances for petroleum products in the absence of solvents or other commingled chemicals. They indicate that these petroleum compounds can readily biodegrade and subsurface and not pose a hazard to vapor intrusion. Is that the case all the time? There are caveats to all these potentials, which United and Land Science can advise you on. And remember, I posed that initial question, what is vapor intrusion? I am sure many of you saw vapor states and internally rose your hand. In some cases, you can have vapor intrusion issues in the absence of soil and groundwater contamination. You can have sites that conduct remediation and residual contamination degrades and off gases with no pathway for it to escape to ambient air. Certain remediation technologies can introduce air into the subsurface that can push vapor phase gases through preferential pathways onto your site. Those pathways can be through sewers, utilities, or natural geologic formations. Most importantly, not many cost-effective remediation technologies will wholly eliminate the VI pathway. We've evaluated sites 20 years post-remediation that still have residual contamination high enough to affect VI risk relative to the proposed development. There's a lot to unpack relative to potential source chemicals for vapor intrusion. We are used to seeing typical dry cleaners, automotive repair, gasoline stations, and your general industrial site. But there are also explosive gases from landfills and natural radon sources that can affect indoor air over time. As we start to bring dilapidated properties back into reuse, we are running into more complex and challenging sites. From United's perspective, we are starting to see more challenging sites in the last several years with chlorinated solvents and methane. From a developer perspective, methane is probably one of the most scary since it can kill right away due to it being an explosive gas. It definitely raises the bar, if you will, for selecting the correct mitigation strategy and understanding the contaminant you are dealing with. In a sense, beyond radon, methane has a significant contribution to the beginnings of vapor intrusion and was a precursor to where VI has come today. As many petroleum compounds rapidly degrade over time, they will end up off-gassing methane or other constituents that will degrade into other daughter products. These lead to evaluations for mitigation down a long-term exposure pathway. What this means is you cannot just look at vapor intrusion as a snapshot in time, but as a holistic approach going from now and into the future. And what's that risk mean to an individual as they occupy the property? As I indicated on the previous slide, you may have a petroleum product that can readily biodegrade, but in many cases, you could also degrade into methane, inadvertently causing a new source for VI. Another pathway that has been hitting the news is polychloroalkyl substances, or PFAS. With this imminent regulatory determination by EPA, we will definitely see another layer of change, if you will, in the evaluation for the VI pathway. This list you see right here will definitely get larger as we understand the pathway more and how these constituents interact over time with each other. This is why VI is an ever-evolving pathway. Individuals considering the purchase or reuse of certain properties must take into account the potential receptor or the end user for the structure. Depending on its short-term or long-term goals, there can be liabilities associated with potential vapor intrusion. Failure to take this into account for your end use can expose you or a future buyer to potential cleanup and mitigation costs, as well as the likelihood that these properties have a valuation change. Perhaps most importantly, though, evaluations of risk posed by vapor intrusion is critical to ensure the safety of the residents, employees, or children that occupy the building. Vapor intrusion, as you can see, is a complex issue with significant consequences if it's not handled correctly. As such, it is important to consult with your environmental attorney in order to successfully navigate the due diligence process in an effort to minimize potential liability of buyers and current owners for vapor intrusion conditions. Now we get to the meat of understanding mitigation strategies. It is a multi-tiered assessment. It starts with those pesky phase 1 environmental assessments. Although I say pesky, it is an important step that gives us all a window to the past to understand the previous uses as well as the current visual conditions. A second step is always going to be initial and targeted assessment of soil, groundwater, and soil gas to evaluate the potential risks from the operations on site, past and present. Site sampling allows us to understand the current conditions relative to those potential risks and the potential for any off-site migration of chemicals in the groundwater table. NIAG Consulting never evaluates and selects a product in a vacuum. We bring multiple stakeholders in to understand the feasibility, costing, protectiveness, and functionality of the system. It is something that requires design team coordination and buy-in from day one. We want all the parties involved to see the barrier mitigation as part of an overall project deliverable. As consultants, it's important that we make a concerted effort to educate during this process. Once we evaluate and select a product, a design will be drafted in consultation with the architect and structural design teams to assure applicability with your development. During the installation, United will be on site to observe and document that installation. Again, each site should be treated as unique. What challenges could exist outside of protecting the on-site future occupant? Does your development need utility dams to prevent migration to other portions of the site or off-site? With explosive gases such as methane, is building mitigation enough? All these play significant roles in your design strategy. And with that, I will give it over to Jason to talk about mitigation technologies.
Thank you, Spencer. We do have the ability to support United Consulting in a variety of ways. We have a full suite of vapor mitigation solutions for both new construction and existing buildings. I'll get into specific technologies and how they differ, but I would like to point out that we do have a technical department that can support some design assistance as well as peer review. We've developed a full QA/QC process to ensure that our systems are installed to maximize their effectiveness. This is accomplished by using certified installers. A great design using the best mitigation system in the world can be rendered useless if the system isn't installed or tested properly. We also have the ability to get on site and lend technical support in the field. I regularly visit sites while an installation is underway to get feedback and ensure that the install is going according to plan. As mentioned, we do offer some limited design assistance in support of United Consulting. Oftentimes, we'll review soil and groundwater analytical results in order to assist with barrier system recommendations or venting layout. Every site is unique, and they will always require a certain level of evaluation before deciding on a particular system. This happens every time for every project to ensure that collectively we are providing the best possible solution for every situation. We also offer engineering support and a variety of CAD or custom drawings and specifications for submittal packages. There are a number of things to consider when choosing a barrier system, but two of the possibly most important considerations are chemical resistance and constructability. A barrier system that has amazing chemical resistance isn't helpful if it's overly complex to install or difficult to perform QC. Key points about a land science spray applied barrier: our systems meet or exceed all regulatory guidance while offering the highest levels of chemical resistance in the industry. They're easy to apply in the field, again, giving us that good constructability. They're very durable, which is obviously important for a construction site. And lastly, we have several layers of QA, QC to ensure that our systems are being installed to meet the design requirements from Spencer and the team at United Consulting. As an example of our nitrile advanced spray and seam durability, this is a picture of a monoshield installation from last year. On this project, 100,000 square foot of monoshield was installed the day prior to the concrete pour. And that night, a huge storm came through, blew the barrier around like a napkin, and honestly, this picture really doesn't even do justice to how bad the storm was. At first, we thought the entire barrier would need to be reinstalled, which unfortunately would have cost everyone involved a lot of time and money. Between getting new system components shipped to the site, the labor to reinstall the barrier, delays to the concrete pour, it was quite literally looking like a nightmare scenario. But as it turned out, none of that ended up being true. As you can see here, the barrier system was untwisted, pulled back into place. The nitrile advanced spray applied seams held everything together across the entire system. Only minor repairs were necessary. The applicator completed a smoke test as part of our QA/QC process to ensure the integrity of the installation. Using a barrier system with spray applied seams over a tape system saved what would likely have been significant delays and additional costs to the project. So what's special about chemically rated barriers, and how does a land science barrier system differ from others? Our goal is to reduce the risk and exposure for sensitive receptors. To accomplish that, we've developed several new technologies in our space. Our first major advancement and patented technology is our nitrile modified asphaltic spray material. If you've ever worked with chemicals or been to a doctor's office, then you're likely familiar with nitrile gloves. Nitrile was first introduced back in the 80s, and it has great chemical resistance to oils and acids. Even the auto industry uses nitrile material for certain gaskets and other parts for these same reasons. So nitrile modified asphaltic spray is used in all land science subslab barrier systems due to its amazing chemical resistance. Another land science advancement and patented technology is our metallized film layer, which is incorporated into some of our barrier systems. If you've ever been to a kid's birthday party or a grocery store, you're likely familiar with metallized films. They're used in balloons, potato chip bags, and many other items. This same material is even used in emergency blankets. The technology allows us to have industry-leading diffusion coefficients while remaining flexible and easy to work with. For the past 15 years, land science has been on the cutting edge of vapor intrusion mitigation technologies. Based on the material innovations I've mentioned here, and we also introduced 3 chemical barrier technologies, and those include TerraShield, NitroSeal, and MonoShield. And we're not stopping there. We're constantly working to develop other new technologies and solutions to help keep land science at the forefront of our industry. So if Spencer or any of the other pros at United Consulting are creating a vapor mitigation design, it's unlikely that water vapors are going to be the main concern. So why do I point that out? Well, first and foremost, it's because there's a massive difference between chemical vapors and moisture vapor. Unfortunately, some people use the term kind of generically for vapor barrier to describe any system that's installed below concrete. It can be misleading or even dangerous if we're trying to mitigate chemical vapors from a chlorinated solvent plume, or even more immediate concern that we're seeing quite often these days, which is methane. Our spray-applied chemical barrier systems can provide double duty for moisture vapors, but they are intended first and foremost for chemical vapors. You don't want something designed for water vapor being the only layer of protection between chlorinated solvent vapors and the people living or working in the building above. Those that have been on site during an install may notice that the picture on the left looks a little strange. Is that a taped system with spray-applied material? Well, it is. The project was dealing with a variety of challenges, including trouble passing a smoke test. Ultimately, that tape had to be modified in order to meet regulatory requirements. Once the design changes were approved, one of our installers was called in to spray over the entire existing barrier in order to make a vapor-tight seal and pass the smoke test. It was a really great example of finding a unique solution to help a client meet some regulatory requirements. We run up against a number of systems out in the field, and I'd like to take a second to touch on some of the limitations that we typically see with a tape system. I'll make an assumption that most of the people have used tape before. I'll also assume that most people have tried to apply tape to a dusty or damp surface. Tape, plastic, dust, moisture, or condensation, etc., don't always get along, and an incomplete seal leaves a major pathway for vapors. If we're trying to mitigate a chemical vapor or a methane site, that can be a very dangerous situation down the road. Another consideration is activities after a barrier system is installed. Will equipment be driving onto the barrier after it's installed and inspected? The machine you see here is a laser screed, and every time it moves, it has the potential to open up a seam, or worse, tear the actual sheet membrane. We deal with laser screeds on our projects all the time, and we also have some specific requirements for how they're used once our barrier is installed. This webinar really is an opportunity to help educate, and I want to kind of pull the curtain back a little bit and share some of what we see in real world examples and explain the right way vapor mitigation design system choices are so important. In some situations, such as the brownfields project, construction cannot proceed without the chemical vapor mitigation system being approved by the regulators and inspected once installed. So now that we've clarified what doesn't constitute a chemical vapor barrier, let's discuss what they are. The regulatory community has a few different qualifiers to help ensure that we're on this right track. And as an example, EPD requires some specific chemical resistance testing as well as a thickness requirement. The US EPA also has a minimum thickness requirement. And ideally, at some point, all states will have similar guidance or requirements for chemical vapor mitigation. The VI industry has seen massive growth over the last decade, and I'm sure that you probably noticed this as well. We're seeing many states implementing regulatory requirements and specific guidance for VI projects. We're also seeing many professional organizations such as ITRC, ANSI, ARST, and AVIP working to help standardize some best practices for the industry. Land Science is involved with these groups to ensure that our products provide the necessary performance and go well beyond those minimum performance specs in most cases. So now I'd like to provide a little more detail about each of our barrier systems and typical usage. I'll start with our mono-shield barrier system, which is a fantastic solution for large warehouses or retail developments where regulatory requirements aren't necessarily the driving factor and risks are considered low. This is a single layer composite system with spray applied seams. The system can be installed extremely fast, especially in a warehouse application. We also have a low profile passive venting system that we recommend as part of our sub-slab barrier systems. Our TerraVent system ties into a standard PVC vent riser and has the ability to be used as a passive system or even in conjunction with an active venting system. Our innovative metallized film sets the standard for chemical vapor diffusion, a system that, again, is backed by our unparalleled design support, warranty, and network of certified installers. When I say this system can be installed fast, I mean it. I've seen our certified installers on a warehouse project install upwards of 60 to 80,000 square foot per day. If you have a demanding concrete pour schedule, I would absolutely want to use a spray applied system for that. Up next is our NitroSeal system, which incorporates multiple layers of protection that starts with our nitro base layer with an HDPE geotextile. The next component in the system is a full 40 mil layer of our NitroCore spray material, which is our, again, unique nitrile modified asphaltic emulsion, which also provides additional protection against vapor transmission and has been proven to offer exceptional chemical resistance. This layer also creates a highly effective seal around slab penetrations and eliminates the need for mechanical fastening at termination points. The final component is our Man Science bond layer that provides additional protection before the concrete is poured. So this system is most commonly used in mixed-use multifamily projects that require a higher level of protection and have lots of penetrations to deal with. NitroSeal is one of the most popular systems that's being used in the Southeast region. TerraShield is our most robust and industry-leading system that incorporates our metallized film and the nitrile modified spray. This system also includes our Land Science protection fabric, which acts as a ripstop protective layer. This system offers the highest levels of protection in the industry and is approved by multiple regulatory agencies across the US. Again, a great product for sensitive receptors in schools, daycare facilities, multifamily housing projects, etc. TerraShield system allows clients to redevelop otherwise highly contaminated former industrial sites while providing the best possible protections for the future inhabitants. So we've made our way through all of the sub-slab systems for new construction, but what if we're dealing with an existing building? Well, fortunately, we also offer a vapor intrusion coating system that's designed specifically for existing buildings, and it's known as RetroCoat. This technology has over 10 years of performance history and is an excellent option to consider either in conjunction with or in lieu of sub-slab depressurization systems. RetroCoat is a unique epoxy system in that it has been approved for use by many of the brownfield sites across the US. And what's different about our system is that it's a zero VOC product. Obviously, you don't want to introduce VOCs into an area where we're trying to mitigate them. RetroCoat finishes to a high gloss, easy to clean surface that's impervious to vapor and moisture transmission. It's also available in a variety of colors. RetroCoat can be applied on concrete, CMU, tile, brick, and even metal. If you want some enhanced slip resistance, you can also incorporate an aggregate into the mixture. So construction in general is challenging, and installing a chemical vapor barrier is no different. Buildings have utilities, and those utilities need to get from the outside to the inside while maintaining the integrity of the barrier system. Some projects have more than others, but you'll always have plumbing and conduit penetrations, seams, and the foundation perimeters to deal with. Depending on the site, we have a variety of solutions to overcome these challenges. In some cases, we can simply use some barrier material and spray, while in other situations, we recommend using a trial grade version of our NitroCore that's called NitroCore Detail. NitroCore Detail has a thicker consistency, similar to peanut butter, which actually allows the applicator to fill small gaps. This is one of the best solutions when dealing with a large cluster of pipes. Using the correct material will strengthen those susceptible points in the system, and most importantly, providing a tight seal at all penetrations and then passing a smoke test. This is a great example of how easily our system can be installed at somewhat challenging sites due to penetrations and uneven surfaces. Here we have our nitro base layer going down. Our systems have the ability to overcome all of these challenges in a timely manner. And once the base layer is down, the certified installer will then spray all seams and penetrations to ensure a vapor-tight seal. And then here we see them installing the land science bond layer, which is the final layer before rebar and concrete. We purposely use a light color so that it's easier to see any tears in the system. And it's a major contrast from the black material that's sprayed below it. Quality control assurance is a major facet of any vapor mitigation system installation. And these extra steps will help to ensure that a great install and reduce future risk for the end user. For all spray applied barriers, there should be many layers of quality control assurance in place to confirm that the system is installed properly. This starts with the installation being completed by an applicator that has been certified and trained by the manufacturer. The installer will work together with the inspector to conduct thickness verification of the spray layers, as well as doing the smoke testing. Smoke testing is performed to ensure the integrity of the system and to find any pinhole leaks that wouldn't otherwise be seen with a simple visual inspection. United Consulting will typically be on site to document and oversee the installation, as well as the QA/QC process, which may include a pre-pour inspection to identify any damage that may need to be repaired prior to concrete placement. So to touch on sequencing for repairs, if the concrete is already poured, the tape system will likely never be able to reseal. Repairs prior to concrete pour or leaving blockouts are extremely easy to complete. We have detailed drawings for the installers to be able to follow, ensuring that they use the appropriate layering. Post-pour, well, those are a little bit more difficult, simply because the installer does need to be more involved to ensure that they have enough barrier material available to get the correct overlap. This type of repair will involve some saw cutting and chipping of concrete to expose the barrier, and then tie into existing barrier using a combination of spray and NitroCore detail material. And then last second repairs, even while concrete is being poured, are not typically a problem for spray applied barrier systems. As you can see from the image here, a small repair is being made while fresh concrete is literally inches away. The concrete guys on this project noticed a small cut in the barrier and communicated the issue to the superintendent, who was able to get the installer to make an emergency repair. And in this case, the installer was able to use our trial grade material called NitroCore detail again to completely seal up the tear so that the concrete pour could continue. And now I'll hand it back to Spencer.
Well, thanks, Jason. It's very important that we have great QA/QC and that it's always best with a great client, great design team, and their buy-in and coordination. Again, it is important that we coordinate with all stakeholders. This includes the barrier manufacturer, land science, relative to the type, appropriate installation methods during construction, and most importantly, its protective characteristics current and into the future. When we talk about the design team, there are multiple levels of engagement relative to a successful project and mitigation design plan. A structural engineer for understanding the pipe allowances and appropriate pass-throughs through design foundation. Does there need to be a change in the mitigation or building to accommodate such a design and system? Understanding, does this have a change in the cost? In most cases, that's a resounding yes. Anytime you're changing a building design, you will undoubtedly cause a cost change. And these are very important that the client and everyone understands so we can work as a team to work through. Through the architectural team, does the vertical discharge pipes have a chase or a place to go without significant bends in the pipe? A lot of projects I've worked on, depending on the architect and design team, there are changes that occur between design and construction. So it's important that you have a great relationship with your architectural team to understand when they have a change that they take you into account during that change. As a rule of thumb, with each bend in a vertical pipe, you roughly see a 50% decrease in airflow. So it's very important for those chases or those pipes to have a home going straight up towards the roof. The GC that's on site, the boots on the ground, understanding for the placement of the pipes, the vertical runs, and roof terminations. Do they understand the importance of the system and when alterations are appropriate and okay to do? When is it appropriate to go back to the design team? And then most importantly, coordination with your trades, your plumber, your electrician, your concrete. Ultimately, they are interacting and are responsible for making sure that when your product's in, that they do not disrupt or damage the product, especially the concrete sub, as they interact with the product as they are putting rebar in and then eventually concrete. It is important that each step from initial due diligence to installation has coordination, understanding, and buy-in from stakeholders, installers, and builders to have a successful mitigation strategy. So case studies. As we wrap up this webinar, I wanted to give you 4 examples of projects that had unique challenges. It is the best way for you to understand the implementation of a vapor intrusion mitigation system. I am hopeful it will give you perspectives, examples of something that's simple and straightforward, something unique, and something that challenges you from a mitigation standpoint. These, of course, only scratch the surface relative to the types of projects United and Land Science have been involved in over the years. Continuing through the initial steps of planning into implementation, this is an interesting, straightforward redevelopment with an on-site former automotive source, but limited to a specific area. Initial due diligence, those pesky phase 1s, was conducted for this historical automotive repair facility, which had adjoining residents to the west. The former automotive repair facility had lifts in the ground, had soil contamination, which was limited to petroleum compounds with minor solvents and low concentrations of PCBs around the lifts that were in the ground. Groundwater impacts were not identified on site. So a 2-tiered mitigation approach was conducted. As you can see in the pink area of the site, a nitrile seal composite layer system was installed in the area of known impacts. For the remaining portion of the proposed redevelopment, monoshield was selected as a preventative, cost-effective approach, which also addressed the potential for radon. This is a great example of a targeted mitigation where it counts and preventative measures into the future. For an adaptive reuse multifamily, this is an example where the project site had an existing building that was on historic preservation and could not be demoed. It was a stockyard for over 100 years, multiple potential sources of issues on site from those operations. The known impacts to soil were mainly petroleum solvent and industrial fill. As we all know, industrial fill is extremely variable and hard to identify exact sources for those different constituents we identify. Groundwater impacts included off-site solvents that were migrating towards the project site. The mitigation approach was twofold on this project. It was a NitroSeal application for new construction and a retrofit NitroSeal installation in the basement level of the existing building. Coupled with vertical damp proofing applications, the mitigation encapsulated and provided a successful adaptive reuse for this project. For a look at a more complex multifamily development, we have this project in downtown Atlanta. Multiple impacted properties enrolled in different programs with different regulatory endpoints, unique and differing contaminants. Looking west to east across the project, as you can see in the top right corner, the site was a junkyard, former Atlanta Metals, the purple area. It was bifurcated by a railroad line, the Atlanta Beltline, railroad spur. The green area was a commercial dry cleaning facility, former Aramark. And then the eastern, almost half of the site was a metal scrapyard. Each of these sites were enrolled in the Georgia Brownfield program, with one of them also being in the voluntary remediation program and in HISRA. Impacts included degraded petroleum impacts along the southwest corner of the property. The sources for this was a coal yard that fed the railroad prior to the 1940s. Other significant impacts included a solvent release from the commercial dry cleaning facility that went through several types of remediation approaches over the years, including blending and targeted soil removal actions. Those approaches prior to our involvement did not lessen the significance of the VI issues on site. To understand the nature of the contamination, 3D visuals were created to help understand the levels and the depths relative to the existing site geology. The approach, again, was two-tiered based on the nature of the building developments and the known contaminant plumes on site. In this case, different technologies for different issues. NitroSeal composite layer system was implemented for the solvent impacts, knowing the future PCE to VC, that tetra to vinyl chloride pathway. For the underlying petroleum area and areas outside of the plume, a modified composite layer system was installed. Generally, when we talk modified, though, we are talking about using components of different level products to create a cost-effective solution for our client. Again, it's another reason why it's important to involve the design team to allow for the development and mitigation designs that are protective and cost-effective for our clients. Lastly, another example of understanding your conceptual site model. Remember the steps to properly evaluate the risk to the occupants. This former watch manufacturing plant had a historical solvent release to soil and groundwater. Significant soil remediation in the building by United was conducted recently, and groundwater modeling and remediation has gone back as far as 1990. This site in particular demanded a creative, cost-effective solution to allow for future development of the existing building. This included the installation of a NitroSeal system over the remediation area and an additional 25,000 square feet of building to the north and trenching and venting in down gradient areas. In the future, once this building is redeveloped, RetroCoat, that topical system we were talking about earlier, would be applied to all the suites in the commercial buildings and inspected and certified prior to occupancy. To sum it up, you must understand the history of the site, the potential contributions to the VI pathway from interior and exterior sources, the sources themselves. Do you have a soil, groundwater, a vapor issue? What are your constituents of concern? Are they solvents? Are they petroleum? Are they other emerging contaminants? Could those constituents degrade over time, and into what exactly? Understand your pathways. Your reuse and risk. Is this a residential? Is it a commercial property? Is it a park? In some cases, mitigation may not be appropriate. And in most cases, mitigation is appropriate. Your design implementation. Understanding your development. Is it new? Is it a retrofit? And what system is protective of the aforementioned things? And how that system will affect conditions into the future. And most importantly, your design team coordination. As you can see, there are multiple stakeholders involved that can interact with your system. It is important to understand where the design fits in and how it can affect other components of your development. Any number of these are needed to adequately evaluate the vapor intrusion pathway and the level of mitigation right for your development. As we speak, the vapor intrusion pathway is evolving. Agencies have released guidances relative to vapor intrusion and specifically mitigation. For the most challenging projects, we are starting to see additional design steps not seen on a typical VI project. Again, this is an evolving science, and as we learn more, we adapt for the better. Sampling and diagnostic ports. To be able to access the subsurface post-construction for future testing programs. As are our preferential pathways, what is forgotten is the future pathways created through development of a property and displacement of the gases laterally. On the more challenging sites, we are starting to see future testing being needed to understand what happens to that plume post building construction and what it does to the potential occupant and the system itself that has been installed. Installation confirmation QA/QC testing, inclusive of testing the pressure differential between the subsurface barrier and the vertical discharge piping, and indoor air quality testing, inclusive of testing indoor air within units to confirm the effectiveness of the system. In some states, they even have a minimum number of required units to test. Again, think radon on steroids. United always recommends to our clients that in any mitigation strategy that includes an indoor air component, that it be closely monitored post-construction to make sure a building construction material does not become an unknowingly background contaminant. We all love new car smell, but we all know there are chemicals that can off gas. The same applies in construction. It can occur in carpet adhesives, construction glues, paints, and general cleanup prior to occupancy. That is why United is at the forefront of vapor intrusion mitigation systems with technologies such as land science barrier technologies. With rapidly evolving regulatory requirements, it's important that we have products that can adapt, flex, and remain cost effective with those requirements.
All right, thank you, Spencer. So that concludes the formal section of our presentation. And now at this point, we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple quick reminders. First, we will be sending out a brief survey after the webinar. We really appreciate your feedback, so please take a minute to let us know how we did. Also, you will receive an email with the recording as soon as it is available. All right, so let's circle back to the questions here. This first question is for Spencer. Spencer, the question is, with emerging contaminants, do you see changes to how evaluations are going to be conducted in the future?
Yeah, definitely more sampling, pre and post construction. For our developer clients, our multifamily clients, this is a challenge. And as the VI pathway grows and as we have a better understanding of it, it's very important that us consultants do more investigation work on the front end that can help reach endpoints with VI and be sensitive towards our clients' potential development schedule, occupancy schedule, and also being protective of the occupant that will be occupying these structures. So it's very important that us consultants do a lot of good work on the front end so we understand what we're getting into and that the mitigation strategy and the mitigation product selected and installed does its job and does it properly and is effective from the beginning.
All right, thanks, Spencer. So here's a question for Jason. Jason, the question is, what can an inspector do to ensure that the install goes according to plan?
Hey, that's a great question, and I would say first and foremost, I would recommend going through our online inspector training program, which only takes about an hour to complete. Beyond that, I would say get involved as early as possible with the project. Join the pre-construction meeting so that you understand the construction schedule, and then obviously work with the installer so that you have an open line of communication and so that you understand when they're going to be on the job site, what they're going to be doing, and then take good notes and obviously plenty of pictures as the installation takes place so that you can create a log that has a good timeline of when things took place, what was taking place at a given time, and then you have a visual representation of what took place as well. So that would be probably my best recommendation for that.
Okay, thanks, Jason. So here is another question for Spencer. Spencer, the question is, what are some typical situations you see on projects with poor communication, and how does that affect the process?
Yeah, that's a very good question. You probably saw earlier in the presentation on Jason's slide on system repairs, we had a building where the GC and the concrete contractor, they were used to the typical, oh, we can fix any penetration we come across, not a big deal. If a pipe's off by 2 inches, not a big deal. Well, no one checked any of the measurements in this building, and they had over 72 penetrations that were off by anywhere from 2 inches to 6 inches. These 72 penetrations required repairs, essentially. They had to cut through the barrier, cut through the concrete. System was a post-tension system to add complexities to it from a foundation standpoint. And they thought they could just spray apply, they just spray a little bit in the hole and they're good. And that's not the case. There's a sequence for the repair. There's inspection work that needs to be done on the consulting side to meet certain regulatory endpoints. So poor communication is a part of it, and poor craftsmanship by contractors can lead to very costly mistakes, and not double checking penetration locations and stuff like that can have a huge effect on a project. And we always want to make sure communication is great to avoid these type of things, and we always bring up the mistakes so the contractors learn from those mistakes or have the opportunity to hear other contractors that have made these mistakes. Another poor communication that we've seen that leads to big issues is elevator pits. They're used to just being able to slap down an elevator pit base, sidewalls, and keep moving. And those sometimes can be huge integral portions of a remediation system. Elevator shafts tend to cause uplift pretty quick and draw vapors in very quickly and push them to higher floors of a building. So it's very important that they're mitigated properly and that they're communicated on the front end that they need to be mitigated properly as well.
All right, thanks, Spencer. So here's another question for Jason. Jason, the question is with cold temperatures impacting most of the US right now, can your materials be sprayed in near freezing temperatures?
Yeah, we are all certainly dealing with some very cold temps right now. I can relate to that even down here on the Gulf Coast. But cold temps create a variety of challenges. First, we need to ensure that the materials are stored correctly on site while not in use to protect them from freezing. Maintaining freeze protection is critical for any of the spray applied materials, as well as the NitroCore detail material, which is in buckets. So with proper preparation, you can spray all the way down to about 32 degrees. Obviously, you're going to need to keep the spray material and your hoses warm. There's a number of different things that will allow you to spray down to those very, very cold 32-degree temperatures. But I would probably recommend that you reach out to me directly so that I can answer a little bit more project specifics offline so that we can make suggestions that are going to apply to a very specific situation. With what I mean by that is what are we dealing with on site? How are the installation crews going to be kind of mobilizing? Where is the spray rig? Where is the material going to be stored? All of those things are going to come into play. So anytime there's a question related to specific site requirements, please don't hesitate to reach out to myself or anyone else on the land science team to give you some recommendations that are probably better suited for a very specific site condition.
All right, thanks, Jason. So here's another question, and this one is for Spencer. And Spencer, it's regarding costs. Can you speak to the cost differential between passive and active systems, and how about the potential for those hidden costs?
Sure. So, a passive system, if you think about its installation, it's, you're putting down the vapor barrier, you're running the vertical stacks to the roof, and then you'll either be putting, a passive, what we call a whirlybird or some type of J-hook with a screen on them. And then typically you're not doing anything to those systems. Where the hidden costs come in is with active systems, the monitoring that needs to be done to make sure A, the blower is active all the time, and then B, is it doing what it needs to do to sufficiently pull the vapors from the subsurface through the building to the roof and extracting them. So in a lot of systems, you'll see monitoring that has to occur continuously. You'll see monitoring that has to be done at minimum yearly. A lot of active systems will include a operations monitoring and maintenance plan that will kind of outline inspection requirements for the building, minimums that the system should be extracting. Are the blowers, running properly? We'll even get into electrical costs per year, where you'll see an uplift in electrical costs through the winter months, and then the hottest parts of the summer. So those are all add-ons, and every one of those add-ons and every individual you are involving in that process to maintain and inspect that system is a cost. And some developers do not take that into account. And where it gets tricky is when a site changes hands and somebody purchases the property, it doesn't understand the minimums that need to go into this. And this is where it gets kind of down a road of unknowns. And those are the things we worry about with active systems. And we definitely want to sit down with our clients and make sure they understand all of those details so they can make a risk-based decision and a business risk decision on what path they want to do and how they want to do it going forward.
All right, thank you very much, Spencer. So that is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. For more information about environmental services from United Consulting, you can visit unitedconsulting.com. If you'd like to learn more about vapor intrusion barrier technologies from Land Science, please visit landsciencetech.com. Thanks again very much to Spencer Cox and Jason Wilt, and thanks to everyone who could join us. Have a great day.